Now in the last video we saw how to get empirical formulas from element percentages. The empirical formula is fine for ionic compounds. It's giving you the simplest mole ratios for the different elements that are in the compound. But when you have a covalent compound, a molecular compound, chemists prefer molecular formulas instead, because they give the actual number of atoms of each type in a molecule. For example, let's look at the difference between a molecular formula and an empirical formula. If I have acetylene, here's the Lewis structure for it. The molecule looks like this. So the molecular formula is going to look like C2H2. Okay? Because there are 2 hydrogens in there and 2 carbons in there. But the empirical formula, the one you would figure out from the element percents, it is going to be the simplest ratio of these 2 elements. Now, a 2-to-2 ratio is the same thing as a 1-to-1 ratio. So you'll get a formula with the same carbon to hydrogen ratio more simply if you do a 1-to-1 ratio instead of a 2-to-2. So the empirical formula will look a little bit different from that. Now, what if I have styrene, which is a molecule that looks like C8. Whoops, let me do it over here. C8H8. What's the empirical formula for that going to be? Well, the simplest mole ratio that you can have, carbon to hydrogen, isn't 8 to 8. 8 to 8 is 1 to 1. So it also has that empirical formula. So here we have 2 different things that have got the same empirical formula. This is the one that people want. This is the one that you get from the element percents. But there is a way to go from the empirical formula to the molecular formula. What you have to know is that there's a multiplier happening here. If you take the empirical formula and you multiply it by 2, you get the molecular formula here. If you get the empirical formula here and you multiply it by 8, you're going to get the molecular formula there. How do I get these factors though? How do I get these multipliers? What you need are 2 things to figure out what that multiplier is. The molar mass of the compound and I'm going to say the true molar mass of the compound. And often this is given in the problem. And you also need the empirical formula weight. Molar mass, let's call it that. So let's figure out what we would do if someone gave us a problem like this. The empirical formula they're going to tell us is CH. The molar mass is found in an experiment to be 104 grams per mole. What's the molecular formula? Here's how I figure out that multiplier in this case, because that's what I really need. I need to figure out that I need to multiply what I need to multiply the subscripts in the empirical formula by. So the multiplier is going to be a number, it's going to be an integer, and it should be bigger than 1. So the bigger thing is always going to go on top. If you get this backwards, you'll be able to detect the mistake, because your multiplier should come out to be an integer, always, and it should also come out to be an integer bigger than either 1 or bigger. So the true molar mass divided by the empirical molar mass. Let's put a box around that. That's worth remembering. Now, in this particular problem, we know what the true molar mass is. That's the 104 that they gave us. What's the empirical formula mass? Well, they didn't give us that, but they did give us the empirical formula. It's CH. So the empirical formula mass is going to be the mass of carbon, which is 12, plus the mass of hydrogen, which is 1. So this should be 13. So my multiplier is going to be equal to 104 over 13, which should come out to be 8. So if the multiplier is 8, then that means I multiply all the subscripts in the empirical formula by 8. So the molecular formula is C8H8. So you have problems where they're asking for a molecular formula. There's two things you need: the true molar mass and the empirical formula mass. Usually what they're going to do is give you the empirical formula, and you have to figure out the empirical formula mass yourself. And they'll give you this, just like this example that I did here. So you'll see a couple of examples like this on the worksheet.